And welcome back to Simple Circuits 101. This is my latest project called
To Dekatron.
3000.
So this is a device which I've designed to give out a variable DC pulse, which in this case I'm using to test a loudspeaker. I've placed a small bead on top of the loudspeaker as a visual reference.
Ooh, amazing!
I like to test out my projects on a breadboard. It helps to iron out any problems before I commit to a more permanent build. This adjusts the frequency. This is the pulse generator. This is the display driver. This is the display. And this is the pulse rate indicator.
Lovely.
This is the loudspeaker under test in the lab, and some beads for visuals.
This is an oscilloscope trace.
So adjust A point there, and B point, and it looks like we've got a 2.2 volts peak to peak. And for those of you watching at home, here's the full stats. If you simulate a damaged speaker by pressing on its cone, you can see the effect on the oscilloscope. I think you could use this effect to carry out a sort of a health check on speakers. Zoom in on the trace, normal response, then compromised.
Yes, that's very clever.
Strip board is basically a perforated fibre board with strips of copper on one side and components on the other. It's the precursor to a proper PCB.
Lots of wires.
That's the 555 timer chip. That's the CD4017 decade counter. That's the timing capacitor. And that is the timing resistor. And those are the display LEDs. This is a very annoying buzzer, which I've put a bit of blue tack on there. Yeah, it's very noisy. Let's put that back. Thank you very much.
Ow, that hurted my ears.
As with many of my projects, I use a 9-volt PP3 battery with reverse current protection. And the same with the probe. Right then, let's try the new project with a speaker. Let's put the negative on there and the probe on the speaker. Yep, sound coming through, that's good. And just pop it on the base there. And as before, I think we'll use some beads there for visual indication. Pop a few on there. So let's see what the frequency can do. We just turn that up. Yep, displays going through, all LEDs.
Wait for it, steady. 1, 2, 3, run away!
Maplin Electronics, gone but not forgotten. Just apply a thin film of lacquer to the copper strips, and that helps protect against the effects of corrosion.
Circuit diagram.
A popular combination, the 555 timer chip and the 4017 decade counter. The 555 timer chip configured in astable mode. The timing components. The decade counter using all of its 10 outputs. A decoupling capacitor to ensure a smooth power supply. These are the display LEDs and its current limiting resistor. This is the probe connection. The pull-down resistor here prevents stray signals from force triggering the decade counter. A very useful feature, the reverse polarity protection diode. Made in England. Well, the sign is anyway. Fabricating an enclosure using PLA+.
Polylactic acid. Plus.
With a honeycomb infill, the build will take about an hour to print. This is the correct way to install a threaded brass insert.
Oh, come on, get it in there. Come on, come on. Oh, you know you can. Just a little bit, just a little bit. Oh, that's it, that's it. Oh, yes.
Rinse and repeat. And so, at the end of 2 afternoons of general faffing in my shed, I give you final assembly.
Looks a bit untidy, but it'll do.
Thread the probe leads into the holes provided and pop on the lid. And secure. Slide the shrouds over the crocodile clips and test for full and free movement.
Rah, rah, rah.
Fully assembled, tested and good to go. Well, thank you for watching, and if you have enjoyed that project, please like and subscribe.
Dekatron, 3000.